Good morning, students. Today in this video, I will be discuss with you people the topic of this chapter, that is ether. Alcohol and phenol already I have discussed you. Now today I will be discuss with you people, that is ether. Now the point is there, what is an ether? Ether are the compound that having this group, single bond or single bond group. Single bond or single bond group. Here the substances, or I can say that the general formula for ether is R single bond O single bond R dash. Here R, whatever R or R dash I have taken, they can be of alkyl group, they can be of alkyl group, or they can be of aryl group. Therefore we can classify the ether in two form. One is that meaning the classification. If I will be discuss the classification, then we can classify it in two form. One is aliphatic ether, and second is aromatic ether. One is aliphatic ether and second is aromatic ether. If I will be discuss with you the aliphatic ether, that is if both R and R dash are alkyl group, then to we can say that they are aliphatic ether. Like the example, if I will be discuss with you people, so this is CH3 single bond O single bond CH3. These both are alkyl group. Second example, CH3 single bond O single bond CH2 CH3. This is the example, both are alkyl group. One is methyl, one is ethyl. That means they are the aliphatic ether. Aromatic ether, we can further subdivide the aromatic ether in two ways. Aromatic ether meaning, if I will discuss, if R and R dash, they can be aromatic or one can be aromatic, that meaning both can be aromatic, or one can be aliphatic or other can be aromatic, or I can say that one is alkyl and one is a aromatic, then also they are the aromatic ether. That meaning the aromatic ether we can classify it in two more groups, that is one of the group is aryl while the other is alkyl. That meaning one is aryl while the other is alkyl. Like if I will be discuss the example ki one is this aryl and one is alkyl, that is with you peoples in this way. Suppose this is C6H5 single bond O single bond CH3. This is the aryl group and this is the alkyl group. So this is the one part of the aromatic ether. The second part I can discuss ki both, that meaning both the groups are aryl. Like second, this is the first part and the second part is there, both the group are aryl. Like C6H5 single bond O single bond C6H5. This is also aryl group, this is also aryl group. So that meaning both they are aromatic ether. That is the simple classification of ether. Now I will be discuss about the nomenclature of ether. Already I have discussed with you in class 11, but then also I will be discuss with you here the nomenclature of ether. How we can give the IUPAC name of the ether. Nomenclature of ether. Nomenclature of ether. Nomenclature of ether. According to IUPAC, ether are named as alkoxyalkane. That meaning, according to IUPAC, they are known as alkoxyalkane. Now the point is there, which part is alkoxy and which part is alkane? Alkoxy, alkane. So which part is alkoxy and which part is alkane? The larger alkyl group, that is called alkoxy. The larger alkyl group form the parent chain, while lower alkyl group is taken with the alkoxy. So if I will be discuss with you, that's meaning this is in which the smaller alkyl part, smaller alkyl part, that will be alkoxy, and the larger alkyl part, that will be the name of alkane. Like if I will be discuss with you, suppose I have CH3 single bond O single bond CH3. You can check out, in the oxygen both the sides the same number of carbon atom is present. That means the alkyl chain, that is of same number. So I can take any part as alkoxy and any part as a alkane. So its name is this is methoxy, because for one carbon that is a oxy, that is a methoxy, and for one carbon this is methane. So its IUPAC name is methoxymethane. If I will be taken the other, like suppose I have taken here CH3O CH2 CH3. Now here you can check out कि one part of one carbon and the other part of two carbon. So according to that, whatever alkyl part is smaller, that will be the alkoxy, and the larger alkyl part, that is the alkane. So the smaller alkyl part, this is of one carbon, so that is known as methoxy, because one carbon is there, so this is known as methoxy. So I can say that this is methoxy, and for two carbon alkane, that is the ethane, so its name is methoxyethane. The other example I am giving you, suppose I have, this is CH3 single bond O single bond this is now here if you will be see, this is one side benzene ring is available and one side methyl group is available. So this is the aryl and this is alkyl, so this is a aromatic ether. The lower number, a smaller part of alkyl chain, that will be of alkoxy, so this is a smaller part, so this is methoxy, and that is known as benzene, so its name is methoxybenzene. Now the same I can discuss with you, like I have here CH3, I have here CH3 CH2O, and this is of benzene ring. This is, so for two carbon, this is of alkyl part and this is of benzene ring, so that is also the example of aromatic ether. Here the lower carbon is of this two carbon, so two carbon is eth, that meaning oxy, so this is ethoxy, and this is benzene, so its name is coming ethoxybenzene. Now the other example I have taken for this, suppose now on both the sides, like this is I have made. Now both the side aryl group is available here, so that is also the example of aromatic ether. If here you will be see, this is the phenoxy, because if I will be write, I can write in this way, C6H5 single bond O single bond C6H5. This is phenoxy and this is of the benzene, so I can say that this is phenoxybenzene, because C6H5, this is known as a phenyl group. So for alkoxy, this is a phenoxy, and that will be related to benzene, so that is a phenoxybenzene. So this is a very simple way by which we can write the IUPAC name of ether. Some more example I will be discuss with you, that is like suppose I have here, this is CS3 CH2 single bond O. Now this is CH CH2 CH3, and this is CH3. This is, now how to give its name. If you will be see here, first of all, though, whatever the larger chain of alkyl group is available here, give the number. So if you will see, the larger chain is this. So this is 1, 2, 3, 4, and this is a smaller chain. So this part, this is of alkoxy. On which number it is available? On second number. On second carbon, this part is available. Before that, whatever we have seen, that is of first carbon. That is why I have given the number. But here, that is lying on the second number. So 2 carbon is available here. So this is 2 ethoxy, because 2 carbon is available. For 4 carbon, this is coming butane. So its name is 2 ethoxy butane. Like some more example is available here. If I will be discuss with you, suppose this is CH3 CH2 CH3 CH2O, this is, and here this is single bond C, single bond CH3, single bond CH3, single bond CH3. Now it's more tricky, it's more tricky for us. If you will be see here, the longer chain here, so 1 2, if the longer chain I will see on this side, this is 1 2 3, so that meaning this part is of alkoxy. Now in alkane, that is of the second number, methyl group is available. So how to write? Firstly the alkoxy, so this will be 2 ethoxy, 2 ethoxy, and on 2, that is a methyl group. This is 2 methyl, for 3 carbon propane, 3 carbon propane. So this is the common IUPAC naming of ether. Now after this IUPAC naming, in my next video I will be discuss with you people the preparation of ether, ki how to prepare the ether. Now I hope you have understand it. I will send you some naming to give the naming of the ether compound. Please check out and try to do it. If any naming that you are not able to do, then you can ask to me. I will be provide you help. Thank you. Good morning, students. Today in this video I will be discuss the preparation of ether, ki how to prepare ether. The first method for preparation of ether, that is from alcohol. First method that I will discuss, this is from alcohol, that meaning by dehydration of alcohol. Dehydration of alcohol. Before that we read out, if we are doing the process of dehydration of alcohol, then we are getting alkene. But if I will be change the condition, then I will getting the ether. Like suppose I am having here CH3 CH2 OH. Now two conditions are available here. One condition is there at 443 Kelvin under concentrated H2SO4. That meaning I am taking here H2SO4 and the temperature is 443 Kelvin. Then the water molecule will be eliminated from here and we are getting the alkene CH2 double bond CH2 plus H2O. This is. But if I want to form the ether, then I will change the condition. The condition is here, this is H2SO4 is available here, the temperature is 413 Kelvin. Then we are getting here ether. This is CH3 CH2O CH2 CH3 and the water molecule is eliminated. That meaning only by changing the condition we can get the ether. How we will get the ether, that I will be discuss with you this, and that means this reaction how it is proceed, that I am discuss. Suppose I have two molecules of ethyl alcohol. This is the one molecule, CH3 CH2OH. The other molecule is, I can write in this way, this is HO CH2 CH3 at 413 Kelvin. H2SO4 is available here. So from here one water molecule is eliminated. Then what is left here? CH3 CH2O CH2 CH3 plus H2O. So this is ethoxyethane. Ethoxyethane. That meaning this is ether. This is ether. Now I will be discuss with you the mechanism of ether. How this mechanism is completed. This is now mechanism of dehydration of alcohol, or I can say that the mechanism of the same reaction whatever I have discussed for ether. Mechanism, the first step for mechanism is there to formation of protonation of alcohol, as was the same first step that we have discussed in the mechanism of the dehydration of alcohol for the preparation of alkene. So first step is formation of protonated alcohol. Formation of protonated alcohol. The same, I'm having the alcohol. This is CH3 single bond CH2 single bond O single bond H. The hydrogen ion from the acid, the bond whatever electron pair are present on the oxygen, so this electron pair will be attack on this positive hydrogen ion. Then we are getting here CH3 CH2 oxygen, this hydrogen will be attached here. This oxygen is given the electron, so one positive charge will be coming. This is the protonated alcohol. Protonated alcohol. Now the second part is available here. This in second part the another molecule of alcohol, that meaning the same ethyl alcohol, that is another molecule of alcohol act as a nucleophile and attack on this protonated alcohol. So I'm having a protonated alcohol. This is CH3 CH2O. Suppose I'm taking here the another molecule of alcohol, hydrogen. This is, and the protonated alcohol is this. I have taken here CH3 CH2O single bond H positive charge electron pair. Now what will be happen here? Whatever lone pair of this oxygen is having, this will be what it will be do. It's very simple. First of all, though, this bond will be give the electron to this oxygen, the water molecule is eliminated from here. When the bond will be give the electron to this, then positive charge will be coming on this carbon. Then this will be attack on this carbon and attach it there. That meaning if I will be see, then the compound is coming in this way, CH3 CH2O this H, this CH2 CH3 will be attached here, and this water molecule is eliminated from here. The bond has given the electron, that is why oxygen has given the electron, that is why positive charge is coming on this oxygen. That meaning we are getting here this product. In third step, that is again very simple, that is in third step the loss of proton, or I can say that deprotonation. Deprotonation meaning loss of proton. So whatever this compound I have, CH3 CH2O, this is the positive, I can write here CH2 CH3, this is the hydrogen. The electron that are present between oxygen and hydrogen bond will give the electron to this oxygen, and from here hydrogen ion is released. So whatever I'm getting here, CH3, CH2O, CH2, CH3 with hydrogen ion. So this is again the ether, that is the ethoxyethane. That means this is the total mechanism of this reaction. Again I'm discussing about this. The first step is their formation of protonated alcohol. That alcohol reacted with the hydrogen ion that is coming from the acid. Then it will be oxygen has given the electron to this positive charge and we are getting a protonated alcohol. Oxygen is given the electron, that is a positive charge is coming here. In second step, the another molecule of this alcohol is behave as a nucleophile and attack on the protonated alcohol. Now this is the another molecule of alcohol. This is a protonated alcohol. Oxygen is a positively charged, so bond will be give the electron to this oxygen to neutralize it, and the H2O is eliminated from here. As the bond is given the electron to the oxygen, then this carbon is getting the positively charged. So this lone pair of oxygen is attack on this positively charged carbon, and this CH2 CH3 will be attached with this oxygen. Again the oxygen is given the electron, so this is getting the positively charged. Now in the third step, deprotonation. Deprotonation meaning loss of proton or removal of proton. This is the bond between oxygen and hydrogen is split up and the electron that are present in bond is given to the oxygen. The positive charge is neutralized and hydrogen ion is released. So we are getting the product CH3, CH2O, CH2, CH3. This is the ethoxyethane, or I can say that this is the ether. This is the very important method. Its mechanism also they can ask in exam, so please see it carefully. Now the second method of the preparation of ether, that is Williamson synthesis. Williamson synthesis, this is the naming reaction also. Williamson's synthesis, this is a naming reaction also. Sometime it will be coming as a naming reaction, so please be aware. Maybe they can ask like a naming reaction also, you should know about it. Now what's happened in this, this is a laboratory method of the preparation of ether. What we'll be doing in this, the symmetrical and unsymmetrical, both the types of ether we can make it with this method. In this reaction, sodium alkoxide is a nucleophile attack on alkyl halide by SN2 process and ether will form. I am discuss about the sodium alkoxide and alkyl halide. This is sodium alkoxide plus alkyl halide, then we are getting here ether. This is the ether. Alkyl halide is there, so I'm release out from here NaX. NaX because sodium is available here. Like the example, if I will discuss the general reaction, if I will discuss with you, suppose I have this is RONA, this is a sodium alkoxide. Alkyl halide is there, this is Rx. I can write it here X R, suppose R dash, suppose I have taken here. Now the oxygen, that is a, the bond will be transferred here because this is a more electronegative, so this is a negatively charged, this is a positively charged. Here halide is a negatively charged, so from here NaX will be react to each other, and we are getting here R single bond O single bond R dash. This is ether and that is NaX. That meaning ether we are getting with the help of Williamson synthesis process. The example, if I will be discussed with you, suppose I have here CH3 CH2ONA, this is a sodium alkoxide reacted with suppose this is Cl CH2 CH3, both the alkyl suppose I have taken of the same, then from here NaCl will be released out and we are getting here CH3 CH2O CH2 CH3 plus NaCl. This is the ethoxyethane. So that meaning I am from the ether. here. It's a very important point is available here ki ether, the alkyl group that should be for the, that means ether, whatever we have taken here, that should be of the primary. It means alkoxide part, that should be of the primary. It is alkyl part, that should not be of the secondary or tertiary, because that they can give us the alkene. That meaning the limitation, if I will be discuss of this, that meaning the better results are obtained if the alkyl halide is primary. So whatever alkyl halide we have taken here, that should be the primary. It should not of the secondary or tertiary, because if it will be the secondary or tertiary, then it will be give us the alkene, that will be not give us the ether. Like the same phenol is also converted to ether by this method. Like suppose I have phenol, suppose I have phenol, like this is the phenol. Sorry, it reacted with firstly NaOH, then one water molecule is eliminated from here, and we are getting here sodium phenoxide. This is ONA, whatever we need it, alkoxide, sodium alkoxide. So this is sodium phenoxide. Now this sodium phenoxide reacted with CH3Cl, CH3Cl, which knows that on oxygen this is a negative charge, and on this positive charge, this is a negative, this is a positive. This negative charge will be taken on the positively charged alkyl group. So we are getting here O CH3 plus NaCl, OCH3 plus NaCl. So this is ether. That meaning this is ether. Its common name is anisole. Anisole. If I will discuss the IUPAC name, so methoxybenzene. So this is also one more. That meaning with the help of phenol also we can make the ether. Now the next method that I will be discuss with you, that is when it reacted with aluminium oxide, that meaning in the presence of Al2O3, alumina, in the presence of Al2O3, ether can be formed. That meaning here we can take the two molecules of alcohol. So this is CH3 CH2 OH. The other molecule I can write in this way, CH2 CH3, in the presence of alumina, Al2O3. Whatever the first method we have discussed with you, in the presence of Al2O3, that will be at 525 Kelvin. 525 Kelvin. From here one water molecule is eliminated, and we are getting here CH3 CH2O CH2 CH3 plus H2O. This is also ethoxy ethane, that meaning we are getting the ether. So that are the three methods, that are the important method of the preparation of ether. I hope you have understand the one method that is very important, that is the formation of ether. So two methods are very important. The formation of ether, one to by Williamson synthesis method, and one is the dehydration of alcohol. The dehydration of alcohol, the mechanism is also very important. So I hope you have understand. In my next video I will be discuss the physical properties of ether. Thank you. Good morning students. Today I will be discuss the physical properties of ether. In the physical properties of ether, mostly two physical properties are available here. Mostly that are the important one. First is the boiling point. Boiling point. If simply I will be say the boiling point, that is BP, that means the boiling point of ether is low. What is the reason ki the boiling point of ether is low? Because the ether have low polarity. Ether have low polarity. Low polarity. Due to this low polarity, due to this, it will be not show any association of hydrogen bonding. It will not show. It will not show any association of hydrogen bonding. So due to the absence of this hydrogen bonding, we can say that the boiling point of ether is low. That is a very simple point is available here. Now if I will be discuss the second point, this is the solubility. So ethers are soluble in water. Ethers are soluble in water. Soluble in water, its meaning कि they are going to form the hydrogen bonding. One side I have told you कि they are not going to show the association of hydrogen bonding, that is why its boiling point is low. But other side I am telling you कि they are going to form the hydrogen bonding, that is why they are soluble in water. Here they are going to form the hydrogen bonding with the water molecule. They are not going to show the hydrogen bonding with its molecule. That is why they are soluble in water, because they are showing the hydrogen bonding with the water molecule. Like if you will be see, suppose this is the ether, this is the one molecule of water, this is the other molecule of water. So this oxygen and hydrogen, they are going to form the hydrogen bonding. Same, this oxygen and this hydrogen is going to, same oxygen and hydrogen going to form the hydrogen bonding. So due to these hydrogen bonding, we can say that the ethers are soluble in water. But the solubility of ether is going to decrease from lower to higher member. It is going to decrease from lower to higher member. The reason is behind this, as it is going from lower to higher member, its solubility decrease, because increase in size the alkyl group decrease the tendency to form hydrogen bonding, because as the size of alkyl group is going to increase, then the tendency to form the hydrogen bonding by that alkyl group is going to decrease. That is why its solubility decrease from lower to higher member. That are the physical properties of ether. Now I will be discuss with you in this some chemical properties of ether also. The first chemical properties of ether, chemical properties of ether also, chemical properties of ether, chemical properties of ether. If the first I will be discuss, this is the cleavage of carbon oxygen bond in ether. Cleavage of carbon oxygen bond in ether. If generally I will be discuss, then the ether are least reactive. Why they are a least reactive? Because they, the very simple reason is there, due to its least reactive, because they are not going to react, or we can say that that is a very least reactive of the functional group. They will be react with only in under drastic condition. They will be react under drastic condition. Under this, the first talk I will discuss, that is the reaction with hydrogen iodide. Hydrogen iodide. Hydrogen iodide, that will be under drastic condition. Under drastic condition. Drastic condition meaning that high temperature or excess amount of this. So under this also, the first step is there when ether is symmetrical. Under this also, the first step is there when ether is symmetrical. Symmetrical. symmetrical meaning on the both the sides of the oxygen the number of alkyl group or the number of carbon chain is remain same. Whenever that will be the symmetrical, then the both the carbon oxygen cleavage take place. Condition is there. When ether is symmetrical, then both carbon oxygen cleavage take place. Cleavage take place. This is the cleavage. I'm writing in short form. Cleavage take place. That meaning like this. This is a alkyl group, sorry, ether group. I can write here like this CH3. Same here, this is CH3. So this is the symmetrical because on the both the side the same number of carbon chain is available. On that time, both the carbon oxygen bond is going to split up. Now, if you will be see the condition, suppose I am having this is ROR. Both the sides the alkyl group is remain same. This is HX. This is HX. Now that is the lone pair. Now we know that ki halogen is a more electronegative. So what's happened here? This is getting the partially negative. This is getting the partially positive. So this oxygen lone pair will be attacked on this positively charged. So from any side the bond can be split up firstly. This one or this one, that is our wish. We are going to split up, suppose this carbon oxygen bond. Now this OR reacted with H, so it will be giving us ROH. This is the alcohol, and this R reacted with X to give us RX. So one carbon oxygen bond is going to split up here. I have told you कि HX is in excess amount. So whenever that will be the in excess amount, then the other molecule of HX now reacted with the alcohol. So like this ROH and the other molecule of HX, that is in excess. So same, partially negative, partially positive. So this will be bond will be give the electron to this positively charged. So now this carbon oxygen bond is going to split up. So this OH reacted with H to give us H2O and R reacted with X to give us RX. So if I want to write the combined equation or overall equation, if I want to write the overall equation, so you can add both the equation. This is ROR, that is ROR, HX plus HX, 2HX. This is alcohol molecule, this is alcohol molecule. That can be cancelled. Now, so what is left here? RX, RX. That meaning we are getting 2RX, and that is a water molecule. So this is a overall reaction for symmetrical ether, and it reacted with excess amount of HX. So that is the first part. Now in the second part, when the ether is aromatic, the second step I will discuss when the ether is aromatic. How that will be in second step when ether is aromatic. Ether is aromatic. Yeah, in aromatic ether. Second step is there in aromatic ether. Aromatic ether. How is it possible in aromatic ether? Whenever the ether is aromatic, then the cleavage take place only alkyl oxygen side. If that is the aromatic, then cleavage take place only the side or only alkyl oxygen side. Only alkyl oxygen side. The reason behind this, because alkyl group has less hindrance. The reason behind this, because alkyl group has less hindrance. So that is why the bond is split up only alkyl and oxygen. The example I will be discuss with you. Suppose I am having here anisole. This is the anisole. It reacted with a hydrogen iodide. This is a partially negative. This is a partially positive. That is the lone pair on the oxygen. So that is going to attack on the positively charged. So the bond is split up between alkyl and oxygen. The reason behind this is the less hinders, that is the more hinders, that is not going to split up between this bond. So this whenever it is going to split up, so H is attached with there. So what we are getting here, this is phenol OH and this is CH3I. So from anisole we are getting here phenol. Anisole, from anisole we are getting here phenol. Like alkyl alcohol, that is unlike alkyl alcohol, phenol is not react further with HI. That is not react further with HI to give aryl halide. The simple reason is there, when we will draw the resonance structure of phenol, if you will see the resonance structure of phenol, so in that places we have seen the partial double bond is there. The partial double bond is available there. So due to this partial double bond, we can say that this is very typical to break the bond between this carbon and oxygen. That is why phenol is not going to further react with HI to give us aryl halide. So that is also the very important point is available here, why it is not going to further react, whereas alkyl alcohol to further react, but this is not. The reason I have explained here, due to the partial double bond or sp2 hybridize, that is typical to break the bond between carbon and oxygen. Now after this the third point is available here, in unsymmetrical ether. In unsymmetrical ether, if I will be discuss the third point, then this will be in unsymmetrical ether. Third point is there, in unsymmetrical ether. Unsymmetrical ether meaning both the sides of the oxygen, the number of alkyl chain of different carbon. Whenever the unsymmetrical ether will be there, like suppose I have taken CH3 single bond O, single bond CH2 CH3. Here you can see on this side only one carbon is available, that is the methyl. On this side two carbon is available, that is ethyl. So this is a unsymmetrical ether. On that time the cleavage take place from least substituted carbon side. Least substituted carbon side, keep in your mind. On that time the cleavage take place from least substituted alkyl side. Alkyl side, least substituted, keep in your mind. Why it's happened, it is going to cleavage from the least substituted, because on that time it is a SN2 reaction. So in the SN2 reaction, the nucleophile will be attacked on least substituted carbon. Nucleophile will be attacked on the least substituted carbon. That is why in unsymmetrical ether, the carbon oxygen bond is split up from the least substituted alkyl side. Keep in your mind that is. Now the example I am discussing with you, suppose I have this, it is going to reacted with HI. Same this is the partially negative, partially positive. So this will be attack on this, this will be attack on this positively charged, this will be given. So the least substituted is here this methyl. So this bond is going to split up. So this is CH3 CH2OH. So what I am getting here, CH3 CH2OH, and this CH3 react with I to give us CH3I. So that means I am getting the ethanol. Now this ethanol, whatever we are getting, this will be can be react with the one more molecule of HI. If that will be in excess amount, then it will be giving us the alkyl halide. That can be possible, it will reacted. Like suppose I am having this CH3 CH2OH and this is HI. This is the negative, partially positive lone pair. This will be attack on this hydrogen. So now this bond is going to split up between the carbon and oxygen. So what I am getting here, HO and H react to give us H2O, and this CH3 CH2 react to give us CH3 CH2I. So this is the product. That is the firstly alcohol we are getting. If that is in excess amount, that meaning HI in excess amount, then the bond is split up. Second carbon oxygen bond is going to split up. That will be from the alcohol. Now I will be discuss the mechanism of this reaction with you people. So in this mechanism, if you will be see the mechanism of the same reaction, I am going to discuss. Suppose in the mechanism I'm talk about the step first. Step first, in step firstly though we know that ki Hi whatever we have, this is going to split up into H positive and I negative. So in step firstly we want to make the protonated ether. So how will form the protonated ether? This is CH3O, CH2, CH3. This is a unsymmetrical. Now this is react with hydrogen ion, that is from Hi. So it is going to attack on this. So what I am getting here, CH3 single bond O, this H, CH2, CH3. This is getting the positive charge because it is given the electron. This is the lone pair. This is the protonated ether. Protonated ether. Now I'm talk about the step second. In step second, the SN2 reaction will be there. SN2 reaction will be there. So the nucleophile, meaning this I negative, that will react from the back side. So this I negative, that is behave as a nucleophile, and this is the protonated ether, that is a positively charged CH2 CH3. This is now this will be transfer the electron towards this oxygen. So this bond is going to split up, that is getting the positively charged. So it will be attack on this, and we are getting what, CH3I, and this is CH3CH2OH. So we are getting the ethanol. Suppose this will be HI in excess amount, the same process is going on. Now from this ethanol, firstly we will make the protonated alcohol. How to make the protonated alcohol, that you can see. This is CH3 CH2OH. Same, it reacted with this H positive. So this oxygen will be transferred the electron toward this. So what I am getting here, CH3 CH2O H H. This is a positive charge, this is a lone pair. This is the protonated alcohol. Now on this protonated alcohol, again the I negative, that is behave as a nucleophile, react from the back side. This is, and this is CH3 CH2O H H. This is a positive charge. Now this bond will be transferred the electron towards here. So that is getting the positive charge. So it is going to attack on this, and this give us CH3 CH2I plus, and this is H2O. This is the mechanism of this reaction. If that is in limited amount till here, in excess amount, then show it completely. So I hope you have understand it carefully. Now the rest of the chemical reaction I will be discuss with you in my next video. Thank you. Good morning students. In my previous video, I have discussed with you some chemical properties of alcohol, in which we have to break the bond between carbon and oxygen. And the last point that I will discuss, that was for unsymmetrical ether. Now, suppose in any ether, the one alkyl group is tertiary. Suppose in ether, one alkyl group one alkyl group is tertiary, then what's happen, whenever the one alkyl group is tertiary, on that time the cleavage of carbon oxygen in ether will take place from tertiary side, because on that time that will be the SN1 reaction, and we know that during the SN1 reaction tertiary carbocation is more stable. Like suppose I am having an ether, this is CH3, C, CH3, CH3O, CH3. Here you can see on one side this is a tertiary, that side is a tertiary if you will see. So on that time how it will react with HI. So whenever it will be react HI, then on that time SN1 reaction take place. That meaning the tertiary carbocation will be formed and the bond will be split up between the carbon oxygen from that side where the tertiary alkyl chain is present. So in this time the bond from here between the carbon oxygen is going to split up. So very simple, this is positive, this is negative, so bond will be given the electron to this. So what I am getting here, CH3OH. So I am getting here CH3OH and this I will be attached here. So that meaning CH3C, CH3, CH3O, sorry, this is I. So this is the product. So that is just different from the primary ether in which side the tertiary is not present. That is just a different. In that side SN2 reaction take place, but here that is the SN1 reaction take place because tertiary carbocation is more stable. I want to show its a mechanism also if you want to see the mechanism. So mechanism of this reaction, this is mechanism. If you will be see the mechanism, suppose I'm having the same, firstly so Hi is available there, so this is going to ionize to give us H positive and I negative. Now I'm having the ether, this is CH3, C, CH3, CH3O, CH3. This is it first step, that is a step first. In step first the point is there, formation of carbocation, formation of carbocation, formation of carbocation, how the carbocation will form. So this react firstly with the hydrogen ion. So on that time to make the carbocation, this bond is going to split up between the carbon oxygen. So this is going to attack on this hydrogen ion. So from here the electron is going to transfer toward this oxygen to make it balance. So this will be CH3C, CH3, CH3. This is a positively charged and this is CH3OH. So this is a carbocation. This is the tertiary carbocation because on that carbon 3 alkyl chain is available here. So this is the tertiary carbocation. Now in step 2, step 2, this tertiary carbocation will be show the SN1 mechanism with the iodide ion, that means with the nucleophile. So this is CH3C, CH3, CH3, tertiary carbocation reacted with I ion. That is a very fast reaction. This is the slow reaction, but this is very fast reaction. So this negatively charged will be attack on this positively charged. So I'm getting here CH3C, CH3, CH3, and that is I. That is the major product. So whenever in any ether the alkyl group is having tertiary side, then this type of reaction will be possible. That meaning that will be of SN1 reaction. Now after this the next reaction that I will discuss, this is a electrophilic substitution reaction of ether. Electrophilic substitution reaction of ether. If you will be see here, electrophilic substitution reaction of ether, electrophilic substitution reaction of ether, electrophilic substitution reaction of ether. So in aromatic ether the alkoxy group is activating group. If I talk about the aromatic ether, so this will be the aromatic ether, this is O, this is R. This is the aromatic ether. Here the alkoxy group. Alkoxy group, this is the activating group. Which one is the alkoxy group? This is the alkoxy group. Alkoxy group. This is the activating group. Activating group. So, or we can say that this is the electron releasing group also. It activates the benzene ring. This will be the electron releasing group also. So it activates the benzene at ortho and para position like phenol. If you will see here how it will be activate the benzene ring at ortho and para position, so that you can see from its resonance structure. Like suppose I am having the aromatic ether. This is the OR, aromatic ether. This is same. This will be transfer the electrons here, and this pi electron will be coming on this place. So what I am getting here, this is here double bond will come R, and one positive charge will come because oxygen is given the electron. This is now this bond will be transferred here, so pi electron will be shifted on this position. So what we are getting here, this is the double bond, that is a double bond oxygen, single bond R, electron positively charged, and this is the electron. Now in next condition, this will be transferred here and this will be giving on this place. So what I am getting here if you will be see, double bond oxygen, single bond R, positive. This is the electron, this is a double bond, this is a double bond. The next condition, if you will be see, this will be transferred here, this is giving back to this. So what I am getting here, this is single bond O, single bond R. This is, if you will see here, this transferring of electron, ortho and para position. This is the ortho and this is the para. So the electrophile will be attacked during this electrophilic substitution reaction on ortho and para position. That is the reason why in electrophilic substitution reaction of ether, the electrophile will attack only on ortho position. Due to this, you can explain it. Now for this I will be discuss the first reaction, that is the halogenation. That is halogenation. First reaction is there. This is halogenation. Halogenation. If you will be see, suppose I am having the anisole. This is the anisole OCH3. Halogenation meaning it is going to react with Br2. Suppose I am taking here Br2, any halogen in the presence of a solvent. This is CH3COOH. So we know that this group, that is a ortho and para directing group. So halogen will be attached on ortho and para position. So we are getting here what? This is OCH3. This is ortho and the next one is on para. So like this we are getting the product. This is ortho bromo anisole. Ortho bromo anisole. And this is para bromo anisole. Para bromo anisole, and this is the anisole. So that is the first electrophilic substitution reaction. If I will be discuss the second one, so that will be the nitration. That will be also for the same condition. Suppose I am having here, this is, or you can show in this way also. In the same I am telling you here, this reacted with HNO3 in the presence of H2SO4. Same NO2 group will be attached on ortho and para position. This will be OCH3. This is the NO2 group on ortho position, and here the NO2 group on para position. This is a substitution Substitution meaning one hydrogen is substituted by nitro group here. The hydrogen is substituted by nitro group, firstly from the ortho, then from the para position. So this is ortho nitro anisole, para nitro anisole. Now that is the part of the nitration. This is for nitration. Now the next part I will discuss. This is a Friedel craft. That is the Friedel craft. If I will be discuss the Friedel craft, then you will be see in the Friedel craft there are two types of reaction. Friedel craft reaction. Friedel craft reaction, there are two types. One is alkylation, or one is acetylation. During the alkylation reaction, this anisole will be reacted with methyl chloride or ethyl chloride in the presence of anhydrous AlCl3. Same, suppose this is OCH3 anisole reacted with CH3Cl in the presence of anhydrous AlCl3. Now that will be on ortho and para position. So one CH3 will be substitute the hydrogen that reacted with Cl to release out HCl. So that will be giving us in this way. This is OCH3. This is CH3. Or second is there OCH3, and that is in para position CH3. Their name is there orthomethyl anisole. This is the methyl group. So this is orthomethyl anisole, and here this is on para position. This is the paramethyl anisole. If I will discuss about the acetylation reaction, so this will be reacted with CH3COCl. So suppose this is the anisole, this is OCH3 reacted with CH3COCl in the presence of anhydrous AlCl3. Then what's happen here? If you will be see, so same COCH3 will be substituted the hydrogen from ortho and para position. So we are getting here the product is OCH3, first in ortho position COCH3 plus, then on para position we are getting this is OCH3, this is COCH3. So their name is available here orthomethoxyacetophenone, because this is the acetophenone. This is the orthomethoxy because this is the methoxy group. So orthomethoxyacetophenone, and this is the para position paramethoxy, and that is the acetophenone. So its name is there orthomethoxy acetophenone, and this is paramethoxy acetophenone. So that are the general electrophilic substitution reaction of ether. I hope you have understand the ether. Now this chapter is completed, that meaning alcohol, phenol and ether chapter is completed. In my next video I will be discuss the next unit of the second book, that is aldehyde, ketone and carboxylic acid. Aldehyde, ketone and carboxylic acid. Now thank you.